Now let's take a look at an example of a basic SQL injection attack. In this case, I'm actually using the WebGoat vulnerable application that I mentioned to you earlier in the course. And here I'm actually just going to demonstrate the effects of an SQL injection attack against a vulnerable application. The string that I'm actually using here is the word Smith, right? The actual last name of a user. And then I'm trying to escape that with an apostrophe and then using or 1 equals 1. And let's see how that works. If in this case actually is causing the application to display all the records in the database table to the attacker, to in this case to me, right? Now there's another example that I actually want to give you here, and is in this case is actually using a numeric input to cause the vulnerable application to dump the database records, right? As I mentioned to you earlier, you can do this in your own. You should download this actually vulnerable application, and you can complete all these exercises and do hands-on experience. That's how you learn, right? So definitely I encourage you to download these vulnerable applications and practice in a safe environment. Now, one of the first steps whenever you find a SQL injection vulnerability is to understand when the application interacts with the database, right? This is typically done when you actually have a web authentication form or search engines or any interactive site like a retailing site, like e-commerce and so on, right? So pretty much everything now uses some type of form, whether it's allowing you to search or allowing you to authenticate and so on. Now you can make a list of all input fields whose values could be used in crafting a valid SQL query. This actually includes trying to identify and manipulate hidden fields on the post request, and then test those separately, or trying to interfere with the query itself and generate an error in the application. So and talking about that, actually you should pay attention to any error messages coming back from the application whenever you're actually trying to do that, because it can lead you into further knowledge about what type of strings and what type of attacks, and even probably some type of validation that they may have in place. And you can try to obfuscate in some of the methods that I'm about to assure you in a few minutes. You should also pay close attention to HTTP headers and cookies, right? Now you can start by adding a single quote, as I mentioned to you, or a semicolon to the field parameter in a web form. And then, the first is actually using a SQL as a string terminator, as what I was escaping in the previous example. And if the application doesn't filter it correctly, you may be able to actually retrieve records or additional information that can actually help you enhance your query as an attacker and create your own statements. You can also use the comments delimiter, so -- or the / star and star and the / and many others, right? You can also use other SQL keywords, including the operands like and or, as you saw in the previous example. Now another test is simple to insert a string where the number is actually expected, right? At the end of the day, it should actually monitor all the responses from the application, as I mentioned to you before, any type of error messages, and also including inspecting the HTML or the JavaScript source code, probably using things like the development tools from the browsers as well, right? Because in some cases, actually, these error coming back from the application are the source, are inside the actual source code, and shown to the user if you actually, of course, look at the source of the page itself. You saw several of course, the attacks, but I failed to mention what are the different categories of SQL injection, or what are the different types, main categories of SQL injection. You have inbound SQL injection, which was the stuff that you saw before. You have out-of-band SQL injection. You have blind or inferential SQL injection as well. Right? So those are the three top categories: inbound, out-of-band, and blind. Now we will explore many techniques that actually can be used to exploit all these type of attacks, right? Later in this lesson. Now there are essentially 5 techniques that can be used to exploit a SQL injection vulnerability. Either a union operator that, basically you use that when the SQL injection vulnerability allows a select statement to combine two queries into a single result or a set of results. You can use Boolean to verify whether certain conditions are actually true or false. You can use error base to force the database to generate an error so that you can actually enhance and refine your attack or your, quote unquote injection, right? Now, you also have out-of-band that is actually typically used to obtain records from a database using a different channel. So for example, you can actually make an HTTP connection to send the results to a web server or your local machine running a web service, right? So in that case, actually, you're not displaying it to the user, you're actually sending it to a different channel. Then you also have a time delay attack where you can actually use the database commands to delay answers. And you can use these techniques whenever you actually don't get any output or error messages coming back from the application. And that's what you use typically in blind SQL injection attacks, right? Now, another thing is that SQL injections can be also exploited by manipulating URLs. And as I'm actually showing here. So I have a URL here that is hacker.org. And it just says actually buystuff.php. And then I have ID equals 99 and 1 equals 2. And of course, 1 equals 2 is not true. So I'm trying to manipulate that. Now, let's actually see, what the actual SQL statement it does in the backend, right? So you have a select star from products. In this case, the table was products, where product ID equals 99 and 1 equals 2. After this query is done, you may actually see a message specifying that there's actually no content available, or a blank page. Then you can actually send a valid request to see if there's any actually results coming back from the application, right? So the valid request is actually, instead of sending 99 and 1 equals 2, we change it to 1 equals 1, and then you actually can verify those results. Some web application frameworks allow you to perform multiple queries at once, so you can take advantage of that capability to perform additional exploits. So like, adding records to the database, for example. Now, in this example, I have a user called Omar, and it's actually added to the users tables in the database. And I'm doing that by doing a semicolon after the ID 99, and then I'm putting insert into users usernames, and then the value is actually the user Omar in this example, right? Now you can play with all these SQL statements values, as I mentioned to you before, in that TrySQL tool from the W3 Schools website. So definitely, I will advise you to become familiar with them, right? So if you're not familiar with SQL at all. Now you can also fingerprint the database. So in order for you to be able to successfully execute complex queries and exploit different combinations of SQL injections, you can actually use fingerprinting techniques to get knowledge about that database or that infrastructure. Now the SQL language is actually defined in an ISO standard, so it's ISO 9075. However, some databases are actually different from each other, including the ability to perform additional commands, right? Also the functions to retrieve data and other features. So whenever you've performed more advanced SQL injection attacks, you need to know what is the backend database used by the application, whether it's Oracle or MySQL, Maria database, Postgres, Mongo, and the list goes on and on, right? One of the easiest ways to fingerprint the database is actually to pay close attention to the error messages actually coming back from the database, right? So MySQL error 1064, of course, in this case will demonstrate that there's a MySQL server, right? So you have Microsoft SQL native client error messages that for MS or Microsoft SQL servers, and you have different error messages for Oracle databases and so on, right? So that allows you to at least know how the infrastructure of that or the underlying infrastructure of that database actually works, so you can actually try to construct your messages more effectively for for the SQL injection, right? Now, I mentioned that there's a union exploitation techniques for SQL injection, and a SQL union operator is actually used to combine the results of two or more select statements, right? So in this example, I'm actually using a union operator, and I'm doing a select zip code from some hacker customers, a table, and then I'm doing a union to combine it with another select statement from hacker suppliers, right? So those are the two tables, right? So by default, the union operator selects only distinct values, so you can actually use union all to allow for duplicate values, right? Now, again, you can practice union operators in the TriSQL site and the tool. Now, the way that you actually abuse the union operator and then use them in SQL injection attacks is actually to join a query. The main goal is actually to obtain the value of columns of other tables, right? And in that case, you actually can do things like this, right? So you can select zip code from hacker customers table where zip equals 1, and then you perform a union all, and then you do a select credit card, and then of course from a payments a table, assuming they actually know the table structure, and then of course all bets are off. You can actually probably display results that includes payment credit card numbers in the payments tables, right? Now you also have a Boolean SQL injection attacks, and this technique is actually typically used in blind SQL injection attacks. And the vulnerable application typically doesn't return any type of error, right, in blind SQL injections, but it can return an HTTP 500 message or a 404 or a redirect. So you can actually use Boolean queries against the application to try to understand the reason for those error codes. So in here, I'm actually showing an example of a blind SQL injection using the DVWA intentionally vulnerable application. And again, you can actually try this yourself as an example of a blind SQL injection attack. Now, the other one is the out-of-band exploitation. Another example that I want to actually show with you is how to do out-of-band exploitation of SQL injection. And it's actually extremely useful when you're exploiting a blind SQL injection vulnerability, because you can actually have the database management system functions to execute out-of-band, in a connection out-of-band to obtain the results of that blind SQL injection attack to a separate system, whether it's your laptop or whether it's some cloud service that you're actually pointing, and so on. And in this case, I'm actually showing how an attacker actually exploits a blind SQL injection vulnerability in store.hacker.org. And then the attacker actually forces the victim server to send the results of the query, so the compromised data, to another server called malicious hacker.org. Now let's take a look at a string, a SQL string that is malicious to actually do that type of out-of-band exploitation. So in this case, I actually have store.hacker.org, some PHP file called by me, so byme.php, the ID equals 8, and then in there I'm actually putting UTL HTTP request, which is the command to send the output to malicious hacker.org. So it's another website. And then I'm doing a select user from dual, and then of course I'm escaping that. So in this example, the attacker or me, I'm concatenating the value 8 with the results of the function UTL underscore HTTP request, right? Now, to perform this attack, you can actually set up a web server like Nginx or Apache, or use Netcat as a listener, right? Like, for example, you can do nc-lvp80 or whatever port, but in this case, of course, it's 80 because that's actually function will run it over HTTP. And one of the most common use of Netcat for penetration testing is the concept of creating reverse and bind shells. And in this case, actually, you can actually use it as a listener, right? Now, this website that I'm actually showing here has several cheat sheets for Netcat. So if you're not familiar with that, and of course, you can also use Nginx or Apache. You don't have to actually do that. But Netcat is so versatile and so useful that I'll definitely advise you to get familiar with the tool. And I actually have it here for your reference. And by the way, this hacker or H4C ker.org, I actually own that site, so it's not like a hacking site or anything else. Now, there's also the time delay SQL injection technique, and earlier I actually discussed that Boolean exploitation methodology when you try to actually exploit a blind SQL injection using the Boolean technique. But another trick is actually to induce a delay on the response, and if there's a delay, you can actually assume that the results of the conditional query is actually true, right? So the time delay technique will definitely depend and vary from database type and the vendor to the next, right? So it all depends whether it's a MySQL database or Oracle or Mongo and so on, right? But actually, this is how you do it, right? So you have an example here that I'm actually going to store.hacker.org by me PHP ID equals 8, and then I'm doing and if version, and then of course a version function is like 8, in this case of a MySQL 8 server, then I'm going to sleep for 10 seconds, and then I follow that with false. So in this example, the query checks whether the MySQL version is actually 8.x or not, and then it forces the server to delay the answer by 10 seconds. Now, if you can increase the delay and monitor the responses, you can even set the sleep parameter to a high value, since you don't even need to wait for that long, and just cancel the request after a few seconds, right? Just to actually do that. Now, one thing that I want to also show you is a stored procedure SQL injection. And a stored procedure is actually a collection of one or more SQL statement or reference to an SQL statement or a server, right? Stored procedures can accept input parameters and return multiple values in the forms of output parameters to the calling program. They also can contain programming statements that execute operations in the database, and this actually includes calling other procedures as well. If the server doesn't sanitize the user input, you can actually enter malicious SQL statements that will then be executed within the stored procedure. In this example, I'm actually showing you an example of a stored procedure, and it's pretty lengthy here, but in this case, actually, if you enter a user, let's say Omar or 1 equals 1, and then some password, if the vulnerable application is susceptible to this type of attack, you can actually obtain the password or any sensitive information from the database to that specific user.